In this video, we're going to talk about graphing transformations.
The first kind of transformation is something that we call the vertical shift. So that's something that moves up and down along the y-axis. So if you want to shift your function up, you are going to add k units to your function. And if you want to move down, you'll just subtract those k units from the function. Let's take the example of y equals x squared. Here's the original function. And if I want to shift this function up, I'm going to add 4 units to it, for example, and that actually moves 4 units up on the y-axis. Conversely, if I want to shift it down, I just subtract 4 units from the original function, which is this thing in green right here. And you can't have vertical shifts without horizontal shifts. So instead of adding or subtracting something to the original function, we actually manipulate what we plug in. So if I'm going to shift it to the left, I'm going to add k units to my x value, and if I want to shift it to the right, I'm going to subtract k units from the x value. Let's look at that with our same function of y equals x squared. So I want to shift my original function y equals x squared to the left 4 units. I'm going to add 4 here, and it's actually going to move 4 units to the left. And if I want to move it 4 units to the right, I subtract 4 from my original x, and it actually moves 4 units to the right. Two other kinds of transformations are something that we call compressions and stretches. And that's exactly what it sounds like. When you compress something, you push it in, and when you stretch, you pull it out. So the way that we look at our functions and how we manipulate the traditional f of x is if I actually multiply the function, so some value of a, it can do 2 things. If a is greater than 1, then that stretches my original f of x vertically, or up and down. And if it's between 0 and 1, like if it's 1/2, 1/3, it's going to compress it vertically, which means it's going to shrink it down. And if I have an a here, which is I'm manipulating the a within the x, so if I multiply that by 2 or 1/2 or 50, then if it's greater than 1, it's going to compress it horizontally, or going this way. And if it's between 0 and 1, so if it's a fractional value, it's going to stretch it horizontally. Let's take a look at an example of this using the absolute value function of x. So I want to stretch the absolute value of x vertically by multiplying that whole function by 2. And if you notice, it's actually a lot thinner than the original function, but it is being stretched vertically or up the y-axis, which gives it that thinner look. And conversely, if I want to compress it vertically, or what's drawn here in green, I'm going to multiply the entire function by something between 0 and 1, or I chose 1/2. So if you notice, as it compresses it vertically or along the y-axis, it's like I'm squishing it down, so it's actually wider than your original function. So in order to talk about horizontally compressing and stretching a function, let's take a look at an example of the square root of x. So here's our original function. So when I manipulate my original function of the square root of x and I make the x 2x, when I double it, because that value is greater than 1, it's going to compress it horizontally. Now, when I look at the graph, this blue line is the compression. So it's kind of like saying, as I go along this x-axis here, or the horizon, or the horizontal, it's actually compressing it. So when you compress something, think about a spring. If I push it in, it's actually going to get higher. So that's why the graph looks like that when you compress horizontally. So I'm going to do the opposite here. Instead of multiplying my x by 2, I'm going to actually multiply it by something between 0 and 1, like 1/2. And that's what's graphed here in the green. Now I'm going to stretch it horizontally. Think of that same spring. As I stretch something out, going left to right, it's actually going to bring it down from the original function, which is in red. So this kind of transformation is actually a reflection. So we can actually reflect on the x-axis and the y-axis. And we saw this in previous chapters when we talked about symmetry and even odd functions. So when you reflect among the, or over the x-axis, you negate the entire original function. And if you want to reflect about the y-axis, you only negate the x value within the function. So the example of y equals x plus 1 is this red line here on the graph. So what's represented here with this blue line is actually the reflection of our original function about the x-axis. So remember that we negate the entire function. So if you actually look, if you pick any point on this red line, so if I pick this point right here and I want to reflect it over the x-axis, it will be the same distance here. And here is where I'm going to reflect about the y-axis, or what's graphed in green for my original red function. So that's when I plug in a negative x for any x value, which actually results in a negative x plus 1. So if I take any point on the original function, which is red, so let's pick this point right here. If I reflect it over the y-axis, it'll be the same distance across. And something else we can do with the equation of a function and what we know about manipulating the equation to transform it on the graph is we can actually do a series of transformations using a function. So let's look at an example. So let's look at the example of the square root function, which is f of x equals the square root of x. That little 2 just means it's a square root. So if I want to shift it right 2 units, what I do is I subtract 2 from my x value. So this is what that's going to look like. So now let's shift that function that we have right here, let's shift that down 3 units. When we do that, we subtract 3 from the entire function. So that's going to look like this. And now let's reflect it about the y-axis, which means that we replace any x value with a negative x. So that's going to look like this. So here is our new function after 1, 2, 3 transformations. And just so you have a visual of what we just did algebraically, let's take a look at the graph as we transform this function. So the first graph, the red one, is the original. That's our square root of x. And the blue one is our first step. That's when we shifted right 2 units. So it moves over 2, same kind of curve. The green line represents when we take our now blue graph and we shift that down 3 units. So that's why that went down 3. That's our green. And then finally, how we move our green line here, how we reflect it over the y-axis, it's going to have the same distance, and that's what results in this purple line here. So this function is actually our final transformation.
That's going to do it for this video. Thanks for watching.